Today you're going to learn everything there is to know about function tables and function rules and function equations. Okay, this is kind of a longer lesson, but it's actually really not that hard. Go ahead and go to the next page as soon as you're ready. A function is a relation that assigns exactly one output value to one input value. The number of wing beats, output, depends on the number of seconds, input. The function rule describes the relationship between each input and output. We call that the function rule. You can organize the input-output values and the function rule in a function table. In a function, the input value is also known as the independent variable, since it can be any number that you choose. The value of the output depends upon the input, so the output value is known as the dependent variable. What that really means is that your input, which is your x, is the independent variable, and the output, which is your y, is the dependent variable. Okay? Let's look at a couple of examples. Let me just scroll down just a little bit. Okay. The output is 7 more than the input. Complete a function table for this relation. The function rule is x plus 7. That means that you're taking the x, which is your input, and adding 7 to it. So you add 7 to every input. So what you get, if you have a table, you put the input here, which is your x, your rule here, and your output, which is your y. I'm going to write y there just so we remember that that's your y. Okay, so if we do that, you can see that if our input is 10, 12, and 14, and we add 7 to each one, we get 17, 19, and 21. That's how you complete a function table. Let's look at number 2. The output is 5 times the input. Complete a function table for the relation. The function rule is 5x, meaning 5 times x. Remember, whenever you have a number next to a variable, that number right there is your coefficient. Let's just write that down so we remember. Any number in front of a variable like that is a coefficient, and it's multiplying. Okay, so if our inputs are 8, 10, and 12, we would put in the rule 5x, and we would write 5 times 8, 5 times 10, 5 times 12, and then we would calculate our outputs. 5 times 8 is 40, 5 times 10 is 50, and 5 times 12 is 60. So far, pretty easy, right? Why don't you go ahead and try problems A and B on your own, and then we'll check our answers. The inputs are x, the outputs are y. Your rule on this one is x minus 4, and your rule here is 3x. Okay, hopefully you had time to solve problems A and B. Let's meet up with our new function helper and get the answers to these problems.
Hey there, I'm Freddy Function Burger, and I've got some answers for you. For problem A, your output should have been 0, 3, and 6. For problem B, your output should have been 0, 6, and 15. If you didn't get those answers, please check with your teacher.
Okay, thanks, Freddy. Let me show you how we got those answers, just in case you aren't sure. The way you do this is you simply take the x, plug it into the rule. So 4 minus 4 is 0. 7 minus 4 is 3. 10 minus 4 is 6. For this side, it's simply 3 times the input. So 3 times 0 is 0. 3 times 2 is 6. And 3 times 5 is 15. That is all you have to do for these. Very easy, right? Go ahead and go to your next page. Okay, what happens if you're given the output and you need to find the input? The input and output of a function table can be represented as a set of ordered pairs, or a relation. The input represents the x value, and the output represents the y, just like we just talked about already. And remember, ordered pairs, you should have learned this in social studies already. Ordered pairs are written like this: x, y. X always goes first. So let's take a look at this example. Find the input for the function table. The output is 6, 15, and 21. The rule is 3x, meaning 3 times something equals 6. You can use the work backward strategy to determine the input. If the output is found by multiplying by 3, then the input is found by dividing by 3, because dividing is the opposite of multiplication. So 3 times what is 6? Well, you should know that 3 times 2 is 6, so our input value is 2. What times 3 is 15? Well, 3 times 5 is 15, so our input is 5. And 3 times 7 is 21, or 21 divided by 3 is 7, so that input is 7. Okay, let's try these problems right here, C and D. I'd like you to try these on your own. Now these get a little bit trickier because you have a two-step equation. You have 2x minus 1, and over here 3x plus 2. So these are a little harder, so I might help you out with the first one. If you think about it, 2x minus 1 equals 1. What do you think the input would be? You could try a few numbers and plug them in and see what happens. Something minus 1 is going to be 1. So what minus 1 would be 1? 2 minus 1 is 1. So how do you get this right here to turn out to be 2? Well, that would be 2 times 1, correct? So the answer should be 1 here. 2 times 1 is 2, minus 1 is 1. So let's work backward and think about the next one again. We want our answer to be 3. We know that something minus 1 is 3. Well, 4 minus 1 is 3. So we know that 2 times 2 is 4. And 4 minus 1 is 3. So the input would be 2. How about for 5? Something minus 1 is 5. Well, 6 minus 1 is 5. So 2 times 3 is 6, which 6 minus 1 is 5. So our inputs are 1, 2, 3. Let's see if you can try this one. And we'll have Freddy give you the answer as soon as you've finished. So press pause now and try to solve the problem. Remember, you're trying to get to an answer of 17, 20, and 29. So ask yourself, what minus 2 is 17? And then think how you would get that. Oh, I mean, not what minus 2. What plus 2 is 17? So 15 plus 2 is 17. So you need 3x to equal 15. That's how you should think about it. All right, let's check your answer to D with our friend Freddy.
Hey, Freddy coming right back at you. For this problem D, it's a little bit trickier, but hopefully you got input values of 5, 6, and 9. If you didn't, make sure to pause and ask your teacher for a little more help.
Okay, the way he got those answers is he thought to himself, what plus 2 is 17? Well, that's 15. So 3 times 5 is 15 plus 2. For 20, something plus 2 is 20. Well, 18 plus 2 is 20, so this has to be 3 times 6. What plus 2 is 29? Well, 27 plus 2 is 29, so this is 3 times 7. That's how we got those answers. Let's look at this real-world example. The Gomez family is traveling at a rate of 70 miles per hour. That means 70 times the hours, which is right here. The function rule that represents this situation is 70x, where x is the number of hours. That's the input. Make a table to find how many hours they have driven at 140 miles, 280 miles, and 350. Then graph the function. Okay, so here's where we set this up with our inputs of we set this up with 70x, and our outputs are 140, 280, and 350. And we want to know 70 times what equals these numbers. 70 times 2 is 140, 70 times 4 is 280, 70 times 5 is 350. Remember, if you weren't sure what numbers go here, you could divide 140 by 70 and get the 2. Once you have this information, you need to make ordered pairs. To make ordered pairs, you take the input and the output. So your input is 2, your output is 140. Your input is 4, and your output is 280. And your last one is 5 and 350. Then you graph it. X always gets graphed first. So your graph looks like this, and you could make a line. Okay, go ahead and go to your next page. All right. I'd like you to try problem E on your own. Brianna bikes 12 miles per hour. That's this rule right here, 12 times x. The function rule represents the situation as 12x, where x is the number of hours. Make a table to find out how many hours she's biked when she has gone 12, 36, and 48 miles. The other way you can help yourself is you write hours here because you're timesing 12 times the hours, and miles here so that you know what to put in the boxes. So your answer is 12, 36, and 48. And you want to know 12 times what equals 12, 12 times what equals 36, 12 times what equals 48. Those are your inputs. Then you should create ordered pairs and graph the function. I'd like you to press pause now and do that. Once you have finished, Freddie will give you the right answers. Okay, let's check and see what your answers should have been.
Hi again. The answers should have been an input of 1 hour, 3 hours, and 4 hours. Your ordered pairs should have been 1, 12, 3, 36, and 4, 48, and they should have been graphed on the table.
So 12 times 1 is 12, 12 times 3 is 36, and 12 times 4 is 48. Your ordered pairs will be 1, 12, so you would graph that right about here. 3, 36, which will be 3, 36, right about there. And 4, 48, which will be right about there. Those are your ordered pairs. That's how you would graph this function table. Okay? Great job so far. You will actually be doing the guided practice in your C step, so just feel free to go ahead now to the next page. Okay, now we need to talk a little bit about sequencing. Determining if a sequence is arithmetic or geometric can help you find a pattern. When you know the pattern, you can continue the sequence to find missing terms. Describe the relationship between the terms in the arithmetic sequence 7, 14, 21, 28. Then write the next 3 terms. Each term is found by adding 7 to the previous term. Continue the pattern to find the next 3 terms. So 28 plus 7 would be 35. 35 plus 7 is 42. 42 plus 7 is 49. So the next 3 terms would be 35, 42, and 49. Let's look at number 2. This is a geometric sequence, which means that you multiply. So geometric sequences, we multiply. Arithmetic, we add. Each term is found by multiplying the previous term by 2. You can see 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. The next 3 terms would be 32, 64, and 128. Let's see if you can do these on your own. Okay, press pause now and try to find the next 3 terms. All right, let's check and see how you did.
Okay, let's see how you did. For problem A, you should have added 15 to the previous terms and gotten 60, 75, and 90. For B, each term is found by subtracting 0.5 from the previous terms, so 2.5, 2, and 1.5. For C, each term is found by multiplying by 3, so 81, 243, and 709. For D, you multiply by 2, so 48, 96, and 192.
Okay, so I'm just going to go ahead and write the rules here so you know. This was minus 0.5, this was times 3, and this one was times 2. Sorry, it was a little staticky when Freddy was talking. Go ahead and go to your next page for a little more practice. Okay, what if we need to find a rule? A sequence can also be shown in a table. The table gives both the position of each term in the list and the value of the term. So in this case, your position is 1, the term is 8, 2, 16, 3, 24, 4, 32. You can write an algebraic expression to describe a sequence. The value of each term can be described as a function of its position in the sequence. In the table above, the position can be considered the input, so that's your input right there. And this is your output. You can also always think input is X, output is Y. Okay, so let's use words and symbols to describe the value of each term as a function of its position. And then you find the value of the 10th term, it says. So they want the value of the 10th term. When they say that, that means you're going to put 10 here for n. So if your position is 1 and your value is 3, 2 and 6, 3 and 9, 4 and 12, and then if we had 10, what do you think that would be? Well, let's think about the rule, what's happening. The position is 1 and that's your input. You multiply by 3 to get 3. You multiply 2 by 3 to get 6, 3 by 3 to get 9, and 4 by 3 to get 12. So if you were doing n, like you don't know what n is, you would say n times 3, which is 3n. You can replace n with any value that you want and always be able to figure out what the output is. So in this case, they asked us to make n 10. So we replace n with 10 and multiply 3 times 10, which gives us 30. So the value of the 10th term in the sequence is 30. Okay? So let's look at these two, E and F, and see how you do. If the position is 2 and the value is 12, 3, 18, 4, 24, 5, 30, what do you think the rule is? Think about how you get from 5 to 30, etc. And then replace n with an 8 to figure out what that should be. For this one, for F, you have 3 to 7, 4 to 8, 5 to 9, 6 to 10, and then you have n again, and you're going to use 8 for n. See how you do. Press pause now, and then come back and check with Freddy for your answers. Okay, let's check and see how you did.
Hey, hope you're still finding this stuff pretty easy. For E, it's 6 times the position gives you the value. So 6n, 6 times 8 is 48. For F, you're going to be adding 4 to the position. So the rule would be n plus 4, and 8 plus 4 is 12.
Okay, if you didn't get those, please stop now and ask your teacher for a little bit more help. When you're ready, go ahead and go to the next page. Okay, one more example that we're going to look at here. Okay, the table below shows the number of necklaces Ari can make based on the number of hours that she works. Write a function rule to find the number of necklaces she can make in X hours. So that means X is our input, the number of hours that we work. The number of necklaces that she can make are 5, 7, and 9. Okay, notice that the values 5, 7, and 9 increase by 2. So the rule includes 2x because we're going up by 2. If the rule were simply 2x, then the number of necklaces in 1 hour would be 2. But the value is 5, which is 3 more than 2x. So that means to test the rule, you need to use 2x plus 3. Use the guess and check to try to figure that out. So basically what they did was, you know that each of these is going up by 2 each time. So like 5 plus 2 is 7, 7 plus 2 is 9. So that means that we're timesing the x value by 2, but then we have to add something to 2x to be able to get there. So 2 times 1 is 2, plus 3 is 5. So our rule is 2x plus 3. These are very challenging, just so you know, to try to come up with a rule. So you a lot of times really have to use your guess and check strategy. Okay? You'll be doing the guided practice in your C steps, so feel free to just go right to the next page now. Okay, now, this time you're going to be taking functions and writing equations. You've been solving equations in this unit for quite a while, so this should be pretty easy for you. You can always use an equation to represent a function. So far we've used tables to represent functions, and we've used ordered pairs. The input, or independent variable, represents the x value. This is important to know. And the output, or the dependent variable, is represented by the y value. An equation expresses the dependent variable in terms of the independent variable. That means that you write your equations like y equals something x. There's something happening to x. That's how you write your equations. Okay, so look at example here. Write an equation to represent the function shown in the table. We have an input and an output. 1 and 9, 2 and 18, 3 and 27, 4 and 36, 5 and 45. You can tell that every single input is multiplied by 9 to get the output. So the value of y is equal to 9 times the value of x. So you would simply write y equals 9 times x. You always write your equations like that. Y equals something x. Let's take a look at these problems here. Write an equation to represent the function shown in the table. You have a table that shows 1 and 16, 2 and 32, 3 and 48, 4 and 64, and 5 and 80. See what's happening to x, and then write your equation in the form y equals something. When you're finished, please check your answer. All right, let's check your answer.
For problem A, you should have had an equation that looks like this. Y equals 16x.
You can also graph a function. If the graph is a line, the function is then called a linear equation. When graphing the function, the input is the x-coordinate and the output is the y-coordinate. We kind of already talked about that, and you always graph the x before the y. Go ahead and go to the next page. So let's look here. Let's graph an equation, or graph a function. Graph y equals 2x. So if you get something that says graph y equals 2x, you should make a table of ordered pairs. You select any 3 values for x, substitute these values for x to find y. So basically, if you are given this equation, you know that the rule is right here. So that goes here in your rule. Your y is your output and your x is your input. You can pick any 3 values you want for x. So I like to pick like 0, 1, and 2 because they're easy. They're simple numbers. So you plug those in and then you get your y. So in this case, 0 times 2 is 0. So your ordered pair is 0, 0, the x and the y. For 1, it would be 2 times 1, which is 2. So 1, 2 is your ordered pair. For 2 as an input, you get 2 times 2, which is 4, and 2, 4 is your ordered pair. When you graph it, you simply do 0, 0, 1, 2, and 2, 4. That's your graph, and it's a line, so that's a linear function. You go ahead and try B and C. Remember, you need to make a table. Okay, so you have your x, your rule, and your y. Okay, your rule is x plus 1. Over here you have the same thing. And this time it's 3x plus 2. You can pick anything you want for x, but I strongly encourage you to use 0, 1, and 2. And let's do, go ahead and do 0, 1, and 2 because then we can check your answers better. We all should have the same answer then. Okay? Press pause now and come back when you're ready. Okay, welcome back. This time I'm going to go ahead and give you the answers instead of Freddy just because he runs out of time sometimes. So here, if you do 0 plus 1, your output is 1. 1 plus 1 is 2. 2 plus 1 is 3. So your ordered pairs would be 0, 1, 1, 2, and 2, 3. To graph that, you simply go to 0, 1, which is right here, 1, 2, which is right here, and 2, 3, which is right here, and then there's your line. For C, if we use 0, we get 3 times 0, which is 0. 0 plus 2 is 2. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6, plus 2 is 8. So our ordered pairs are 0, 2, 1, 5, 2, 8. So we would graph it 0, 2, 1, 5. I have to go a little bit off my chart here. 2, 8 would be somewhere up here. And that would be our function or our graph. Okay, let's look at one more real world example. Or maybe two. Martino constructed the graph shown, which shows the height of his cactus after several years of growth. Make a function table for the input-output values. The three input values are 1, 2, and 3, because you see them right here, 1, 2, and 3. Those are the x values. The outputs you can see are 42, 44, and 46. Okay, so we plug them in there. So basically, we just took that right off of a graph. For 4, write an equation from the graph that could be used to find the height, y, of the cactus after x years. Since the output values increase by 2, the equation includes 2x. Each output value is 40 more than twice the input. So the equation would be y equals 2x plus 40. They just figured that out by saying that since these go up by 2, we have to be timesing by 2, so it's 2x plus something. I know that may seem a little bit confusing or a little hard to figure out how we got that. That's probably the trickiest part. But basically you know that if each one is going up by 2, that it has to mean that there's a 2x involved. And so once you know that, you know you have to do 2 times something and add 1 to it and get 42. So you figure 2 times 1 is 2 plus 40. Gives you 42. Okay, go ahead and go to your next page, please. Okay, let's see how you do. Look at this example. The graph shows the total amount y that you spend on books, you spend if you buy one book, and X magazines. Make a function table for the input-output values. Write an equation from the graph that could be used to find the total amount y if you buy one book and X magazines. Okay, so here's your X is number of magazines. Your Y is total amount. So let me help you get started. You first want to find what your X values are. Those are going to be here, wherever you have a blue dot. So I'm going to start with one of them for you. You know you have 1 is one of your X values. You can fill out the rest. Then your Y values are going to be over here. Your first Y value is 20. The ordered pair is 120. See if you can then figure out what the expression is and the equation. So what you need to figure out is, once you have your outputs, let's see here, your outputs are all going to be 20, 25, 30, and 35. That means they're going up by 5 every time. So it's 5 times x plus some other amount. So think about 5 times 1 is 5. 5 plus what equals 20, and that's going to be the rest of your equation. So you would start with y equals 5x plus some amount that you're going to figure out. When you think you've got it, come back and check your answer. Okay, let's check your answer.
Hey there, Freddy's back. This stuff's getting a little bit tough, isn't it? For this question, you should have had inputs of 1, 2, 3, and 4, outputs of 20, 25, 30, and 35, and your equation would have been y equals 15 plus 5x. If you're struggling with this, please pause and for a little bit more help.
Alright, once again you'll be doing the guided practice in the C step, so go ahead and go to your last part of the lesson. Okay, the last part that we're going to be doing is representing functions using words and equations. A runner's distance in a marathon is equal to 8 miles per hour times the number of hours. So it's distance equals 8 times the number of hours. Excuse me while I answer that. Okay, I'm back. Words and equations can be used to describe functions. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, determine what variables to use to represent different quantities. For example, the drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total amount earned T for selling P pies. So our two variables are t and p, and our coefficient is going to be 5. Okay, so you look at the words, and you see that the total earned equals 5 times the number of pies sold. So you let T represent the total earned, okay, that's like your output, the Y, and then P represents the number of pies sold. Your equation is your output, which is the total amount of money earned, so T equals 5, your coefficient, times the input value, which is P. Okay, so the equation is T equals 5P. You can also, if it makes you more comfortable, you can use Y and X always because it's sometimes easier with function. So it would be Y equals 5X because you're used to using that. In a science report, Mia finds that the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths B a non-active person takes in M minutes, and it's 14 times each minute. So you know that B is going to represent the total breaths. Okay, so that's going to be your output. M represents the number of minutes, which is your input. The number of total breaths equals 14 times the number of minutes. So your equation would be B equals 14M. Let's have you try 2 on your own. A mouse can travel 8 miles per hour. Write an equation to find the total distance D, output. A mouse can travel in 8 hours, input. Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies C, that's output, that she can make in 8 hours, input. Press pause, write your equations right over here, and then we'll check your answers. Okay, let's check those answers.
Hi there. Your answer for A should have been D equals 8H. For B, it should have been C equals 36H. If you didn't get those correct, please ask your teacher for a little more help.
Okay, good job. Go ahead and go to the next page. All right, representing functions using tables and graphs. We just did equations, so now let's do tables and graphs. Tables and graphs can be used to represent functions. Okay, tables look like this, right here. Graphs look like this. The student council is holding a car wash to raise money. They are charging $7 for each car they wash. Write an equation and make a function table to show the relationship between the number of cars washed, C, and the total amount earned, T. So T is your Y value, output. Cars washed is C. Your rule is 7C because it's $7 for every car they wash. So they want to know that we have the values here of 1, 2, 3, and 4. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. And 4 times 7 is 28. The equation is T equals 7C. Output equals, so whatever happens to the input. Okay? Now it says graph the ordered pairs. Analyze the graph. Find the ordered pairs, which would be C, comma, T, or X, Y. Always remember that. So your ordered pairs would be 1 and 7, 2 and 14, 3 and 21, and 4, 28. Once you graph them, you have 1 and 7, 2 and 14, 3 and 21, 4 and 28. The graph is linear or a line because it increases by $7 for every single car they wash. Okay? Go ahead and go to your last page. We're almost done. You've done a great job. Okay, the last thing I'd like you to do is these 2 problems right here, C and D. Okay, while in normal flight, a bald eagle flies at an average speed of 30 miles per hour. Okay, write an equation and make a function table to show the relationship between the total distance D, that's your output, that they can travel in H hours. Okay, graph the ordered pairs of the function. Okay, so you can pick any of the input values down here for time and put them in here. So you can choose what you'd like to do there. And then you should graph it and analyze the graph. So if I were you, I would simply stick with the easiest hours, like 1 hour, 2 hour, and 3 hour. Then figure out the distance using the rule, which is 30H is your rule. Graph down here. Okay? When you finish, please check your answer. Okay, your answer should have been, in this case, 30, 60, and 90. Our equation would have been D, which is our output, equals 30 times our input, which is H. To graph them, your ordered pairs would have been 1, 30, 2, 60, and 3, 90. So we would have graphed it like this: 130, 260, and 390. It's a linear graph, it's a line, and that's all there is to it. You'll be doing your guided practice in your C step, and that's it for functions. Good luck with all your practice problems and everything else that you need to do in this topic, and please make sure to ask questions if you need any more help. Bye for now.